Welcome to Ask and Learn.
So for this problem, we have a series circuit, and this is LRC circuit. So in this problem, we want to find out the ratio of V out over Vs, and also we want to get the conclusion that when omega is large, we want to prove that this is a high pass. It is not a low pass. So to do that, we need to figure out this V out firstly. Okay. So the impedance for R, L, and C are given as ZR is simply R, because the resistance does not rely on the frequency of the source. And the impedance for the inductor is J times omega L, right? J is the unit imaginary number, omega is the frequency, and L is inductance. And for the capacitor, the impedance is given as 1 over J omega C. So because these three parts, they are connected in series, so basically the V out is given as ZR plus ZL over total Z. And this total Z is just the summation of these three parts, okay? So if we plug in these values, we should times V. V is the source, the amplitude of the source. So equal to V times R plus ZL is J omega L. And total one is R plus omega L minus 1 over omega C and times J, right? So, and then actually you need to figure out the amplitude of this result. So I just label this by tilde. So the true V out will be equal to V times the amplitude of this complex number. This is a complex number, right? So the amplitude will be given as R squared plus omega L squared and over R squared plus omega L minus 1 over omega C squared. All right? So this is the V out, the amplitude of the voltage. And then we can analyze this V out by setting two limits, omega is small and omega is large. When omega is small, like omega is close to 0, so just look at this formula, you'll see that the numerator will become very small. No, the numerator will become very close to R squared, because this omega L will be crossed out, right? And then in the denominator, this omega will be crossed out, and this R squared is a constant. This 1 over omega C, this one will dominate. In that case, the V out will be close to V times, actually just square root 1 over, this is 1 over omega, this is 1 over omega C squared. So you just simplify it, simply omega V times omega C, which is linearly proportional to omega. But when omega is large, is to infinity, we see that in the numerator, this omega L will dominate, and in the denominator, this omega L also dominates. So in that case, the V out is simply equal to V, right? So now come back to the question. So actually we already proved that when omega is small, the ratio is proportional to omega. That is correct. And when omega is large, the ratio is close to unity. That is also correct. So that's it.